recording.
Okay, did everyone get a chance to copy that down? Okay. I'll give you guys one more minute and then we're going to go through it together. So if you're still copying, just keep copying while we're working. Okay, we gonna start?
Yes.
Okay. If you're still copying, I'm gonna go through it one by one. Can you take it from?
Yep. On this one or that one?
On the other one, because it's gonna record it if I do it here.
Okay.
Yep. Okay, so on the first one, guys, we have a negative number times a negative number. If the numbers I'm multiplying are the same sign, what is my result going to be? Positive or negative? Positive. If they're the same sign being multiplied together, so two positive numbers being multiplied together, or two negative numbers being multiplied together, my result will be positive. So I know that my result's going to be positive, and then I have 4 times 4. What's 4 times 4, guys? 16. So we're going to have positive 16. On the second one, we're going to break it down into pieces, okay? So this is just number 1 with an extra times negative 4 at the end, right? What'd you say, Aubrey?
4 times 4 times 4.
Mm-hmm. But first, I want to break this down first. So we have negative 4 times negative 4. We just said was positive 16, right?
Yeah.
Now we have positive 16 times negative 4. So my positive 16 is a different sign than my negative 4. So my result's going to be what, class? Negative. So what's 16 times 4?
Oh, never mind.
64. And in case you guys can't see that, I'll do it real quick. We have 6 times 4. That's going to give us 24. So I'll put my 4 here, carry my 2. 4 times 1 is 4. Add the 2, 64. So it'll be negative 64. And again, it's negative because we have a positive 16 times a negative 4, two different signs. Okay, for number 3, I'm going to again combine our negative 4 times negative 4 because we already did that in number 1. That was positive 16. And now that's going to be multiplied by this middle 4 here. Now we have the same problem we just did in number 2, except we have two positive numbers being multiplied by each other. So our result is going to be what? Positive or negative? Positive, because we have two positive numbers. The signs are the same being multiplied together. Okay. Now try 4, 5, and 6 on your own. Take about 2 minutes, and then we'll go over it. Okay. Actually, let's do it together because fractions. Okay. So for fractions, guys, what you do is you multiply your numerators first and then your denominators. So I'm going to rewrite this as negative 1 over 3 times negative 1 over 3. Take my numerators, my top numbers. What's negative 1 times negative 1? I'm going to pull a stick for it. Okay, well, you already did it. Okay, so 1. And it's positive 1 because we have two negative numbers. The signs are the same being multiplied together. So it's a positive 1. Then I have 3 times 3. What's that going to give me, guys? 9. Positive 1/9 is our answer. Now, if we have, let's combine these two here. Let's do this bit first. These two positive 1/3. Is my answer going to be positive or negative, guys? Positive. So I'll have 1/9 times that middle one now. Negative 1/3. Multiply across the top. 1 times negative 1. What's my answer going to be? 1 or negative 1? Negative 1, because my signs are different. One of them is positive, one is negative. If they're different, it's going to be a negative result. Then I have on the bottom 3 times 9. What's that going to give me? 27, but my negative is just on my 1, Connor. You see that? So it's positive 3 times 9. 27. My negative is already there. So the answer is negative 1 over 27. Got it? Last one. we have basically number 4 with an extra negative 1/3 being multiplied at the end. So we did number 4 already. We said that was 1/9. And then we're going to multiply that by negative 1/3. So look at your top numbers. 1 times negative 1 is going to give us what? We just did it. Negative 1. And then again, we have 9 times 3. 27. Same answer we just got in number 5. Any questions on the warm-up before I move on? Good to go? Okay. Get out your workbooks. You're looking for... Yeah. You're looking for 116. I'm going to try to find a page number for you guys.
What page is it? I love water.
I'm finding the page number. Give me a sec. It is page 221. 221. I'm writing it up. I'm writing it up top too.
Wait, so on Monday we're watching the video?
So right now, in Mr. Sansoni's class right now, he is recording a review, going over the quiz. You guys are going to be watching that video on Monday.
And then on
Because
Tuesday
he's
we're doing
watching,
tests?
so because everyone's going to be out Thursday, so we're,
What do you mean everybody's gonna be out Thursday?
Like the-
all the math teachers are out Thursday, guys.
Why?
So
Are you leaving?
because we have a department like meeting. So what we're doing is we're recording 2 separate lessons today, and then you guys are going to swap. So Mr. Sansoni's class is watching our video. You guys are going to watch his video.
On
So we
Thursday?
have lessons to do.
I thought we were watching the video on Monday.
You guys are watching a recording that Mr. Roden did in first period on Thursday. So we're gonna have 3 recordings to get you guys all set up. Okay? Yeah.
Okay.
Yeah.
So there's gonna be like no teaching?
We'll be here Monday.
I know, but like, oh, we have to watch the video.
Yeah, but I'll be here to help you too if you while you're watching. Okay. Okay. So if I am trying to find the area of a square, so let's draw it up here. First things first, if it's a square, all my side lengths have to be the same, right? So let's do this first one here, this 1. So if this side is 1, all the other sides have to be 1, right? And I want to find the area. What formula am I going to use? I'll take a volunteer. Connor. What was the first bit? Length times height. So yes, but I'm gonna rename it. You're right, but I'm gonna call it base times height, not length. Base times height, or just b times h. But in a square, guys, remember all of our sides are the same. So our base and our height are the same number. So if I plug in 1 for my base on this first one and 1 for my height, what am I going to get for my area in square units? 1. What about if I use 2? 4, because it's just 2 times 2. 3 is just going to be 3 times 3. So what's 3 going to be? 9. What about 4? 4 times 4? 16. Pretty straightforward, right? So what I want you guys to do, and you guys will do this in your lesson tomorrow that Mr. Roden recorded this morning, is you're going to build out this chart. We're going to make a quick one. You'll make a more detailed one tomorrow. But just write this down real quick. Do you guys agree that all we're doing right now is 1 times 1, 2 times 2, 3 times 3? All those is that number squared, right, to the second power. So 1 squared is just 1 times 1. That equals 1. 2 squared, same thing, 2 times 2. That equals 2. 3 squared is going to equal 9. 4 squared is going to equal 16. And I'm going to keep going here to numbers that are going to be a little higher. And the reason we're writing this down is you guys are going to be able to use this as a cheat sheet for your quizzes in future quizzes. Arabelle, yeah. 2 squared is 4. You are totally right. Good catch. Oh no, I wrote 2. Let's fix that. Okay, 5 squared is going to be 25. 6 squared will be 36. 7 squared will be 49. 8 squared will be 64. I want you guys to all copy this down. You will build a more robust table tomorrow, but for today we're going to need these. So I'm doing one quick because we don't have time to make the full table today. We will tomorrow. But I'm giving you guys this today, and we're going to come back to this throughout the day. and I'm going to go up to 20. Yeah, we're going up to 20. You need to write it down because this is going to be your cheat sheet. It's going to make your life the rest of the day and the rest of this unit a lot easier if you have these. I said the rest of the unit, not the rest of your life. But, yeah. Which one? 7. Yeah, this is 49. Yeah.
How do you know all of these by heart?
I knew him up to 15. The rest I wrote down beforehand.
You know what it is? Is that 169?
Yeah. On the 13. Yep.
196, right?
Yeah. Mm-hmm. Yep. So I'll give you a couple minutes to finish writing down, and then we're going to answer number 2. And it's going to be real easy once we have the chart.
Why are you lying so fast?
So that I can get it done.
I'm already done.
How's your day going, sir?
You need ready for lunch? He doesn't want to tell you something. Good.
Raise your hand if you're still writing, guys. Okay.
Is that? What is that? 82? 88?
What are you looking at? Which number? 17?
7 to the second house.
It's
49.
49. You're only on 7? You're only on 7? It's going to be coming on for the rest of his life. Don't really we had to sit through this. Julian, why don't you just write all the numbers? Yeah, and then do the answers. Are y'all gonna like edit this? Or is Mr. Sansoni class just gonna just sit here for 5 minutes?
No, they can sit through it for next week.
Yeah, they can sit.
But they're also going to be writing this down too. So.
But I don't think it'll take as long as Julian's gonna take.
Well,
Are they hearing this all? Yes. Well, mine is. No, they will. Yeah.
Guys.
Give me like 2 more minutes.
we will have the video too, Julian, to go back to it, okay? And I'm going to keep coming back to this. You'll see it throughout the class, okay? So I'm going to move on. Now, all we're looking for is a square that has an area of 25 units. So we're looking on the right side of our equal sign for a 25. Where is that, guys? We're looking on the right side of our equal sign. So here we have 1, 4, 9, 16, 25, 36. It's right here, right?
Yeah.
And then all you're doing is you're going to the left and you're looking at that number. So 5 squared is 25. Remember, our areas are just base times height, but in a square, base times height is the same. So if our square has a side length of 5, it's the same. We're going to get our area is going to be 5 times 5 if the side length is 5, which is just 5 squared. And in our chart that we just made, we just said 5 squared is 25. So we have an area of 25 square units. So we really didn't do any math, right? Once we have the chart, we just looked at our chart. That's all we're doing. That's how we make the chart. So our side length is going to be, so that's our answer because it's asking for a side length. Our side length is going to be 5 to get an area of 25. Any questions on number 2? Okay. We good? No? Okay. Anyone still writing? No? Okay. Now we're going to move on to the next couple, which is the exact same thing, except now we have a cube. So I want you guys to pay attention in case you don't know how to draw a cube. What I'm going to do is I'm going to draw one square, and then I'm going to draw another one down and to the right, and then connect the corners. So I'll do it one more time for ones that missed it. I drew a square. I drew another square with the corner in the middle of this first square. And then I'm connecting my corners. Okay, everyone got their cubes? So now, for our volume of a cube, no, I just did it a second time so you guys saw it. For our volume of a cube, it's going to be our length, which is the bottom, times our width, times the height. But in a cube, all three of these numbers are the exact same. That's the definition of a cube, guys. So if we have an edge length of 1, our volume is just going to be 1 times 1 times 1. So what's that? 1. What about if it's a 2? 2 times 2 times 2. 8. If it's 3, 3 times 3 times 3. And 4, 4 times 4 times 4. 64. So what we're doing here, guys, is, so these numbers up here, 3 times 3 times 3, is the same thing as 3 cubed. Are you guys starting to see why we call it squares in cubes? It's just the area and the volume of those shapes, okay? So now what we're going to do is we're going to do the same thing that we just did on the chart for squares, except for cubes, but this time we're only going up to 10. So I'm going to do 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is, what is 6 cubed? 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. I'll give you guys a second to finish copying that. Raise your hand if you need more time to write. Okay, one more minute. Okay, so now let's take at number 4. Take a look at number 4. We're looking for a cube with a volume of 125 cubic units. Remember, our edge length is going to be our length, width, and our height. So we're looking for a number cubed that's going to give us 125. So take a look at our chart. What number cubed is going to give me 125? Connor. 5 cubed is going to give me 125. So my edge length is just going to be 5. So I'll do 5 is our edge length. And the reasoning for why we know is that 5 cubed gives us our volume that they specified. Okay, we ready to move on? Copy off the list, Julian. We're moving on. Okay, now you guys see this Venn diagram? I think it's on the next page. Everyone label this with me. On the left, we're going to call these perfect squares. Those are the lists that we just came up with on number 2, that big list we made. And on the right, these are going to be perfect cubes. In the middle is going to be both. And on the outside is going to be neither. Outside of the Venn diagrams. Okay, so we're going to go through each of these. And all we're doing is we're going to our charts that we just made and seeing if we can find them. So look at 50, go back to your charts. Is 50 in either the squares or the cubes, guys? Is 50 listed out? I'll go back to them. No. Look at our squares. 50 is not here. We go from 49 straight to 64, so no 50. In our cubes, we go from 27 to 64. We skip right over 50, so it's neither. So I'm going to put 50 under neither. Okay, what about 121? Is 121 in either of them? Where's that one in? 121 is 11 squared. Is it in our cubes? No. So our 11 is going to go, or our 121 is going to go under our perfect squares. What about 64? Is 64 in our squares? 64 is both, because 64 is 8 squared, and 64 is also 4 cubed. Okay. For fractions, here's what you need to do. Look at your numerator, your top number. Look at that first. Is that a perfect square or a perfect cube, the 81? It's 9 squared, right? What about 100?
Yes, because
100 is going to be 10 squared. So 81 over 100, even though it's not on our chart, our numerator and our denominator are in the chart. So what we can do is I'm just going to rewrite this as 9 over 10 in parentheses squared. So this still is a perfect square because our numerator and our denominator were perfect squares. Okay, this next one I kind of wrote over is a 0. What do we think for 0, guys?
Both.
It's not in our chart, but think about it. What's 0 times 0?
0.
That's a perfect square, right? What about 0 times 0 times 0? So 0 squared and 0 cubed is also going to give us a perfect square and perfect cube. So 0 is actually both. Okay, now this next one, the decimals look scary. I just want you to break it down. Put this into a whole number. Ignore the decimals. Just look at the 27-bit, okay? Look at the 27. See if you can find that in one of our charts. The 27 only. 27 is 3 cubed. Now here's a tricky step. If I have a cube number, I'm doing 3 times 3 times 3, right? But I need 3 decimal places to my right? Because right now this is just 27. If I put my decimal right here, 0.3, 0.3, 0.3, when we do multiplication, remember at the end with decimals, we count the number of digits that we have to the right of our decimal. So 1 here in the top one here in the second makes 2, 1 here in the bottom makes 3. And then we start from the back and we move our decimal that many times. And then we're filling in our zeros. Is this that number, guys? That's the trickiest part of this stuff, is these decimals. So start with your whole numbers, the 27, write it out, and then figure out where you can put your decimal to move it that many places. So we needed to move it 3 places, so I put my decimal right here, 1, 2, 3 places. And I moved it over, and we got what we wanted. So 0.027 cubed is the same as 0.3 cubed. So this one actually is a perfect cube. Yeah, Connor. So we're going to go over slowly. So the first one is a 1. Actually, yeah, let me erase this over here because I can't see it. Let's do the 1 first. We'll come back to the 64. So on the 1, guys, is that in our squares and cubes chart? It's in both, right? It's the first one we did. So that one's easy. Straight in our both. Okay, this last one is a negative. It's a bit tricky. I will tell you right now and write this down. Perfect squares cannot be negative because it's the same number being multiplied by itself. So if I have negative 8 times negative 8, that's going to give me positive 64. Perfect squares, I'll write it down, perfect squares cannot be negative. They can, however, be perfect cubes. So ignore your negative for now. Look at your 64. Is 64 in our chart? What is 64 in our chart? What is the cubed for it? 4 cubed. 4 cubed gives me 64. But if I rewrite this, if I try negative 4 times negative 4 times negative 4, it's like what we just did in our warm-up. That's why we did the warm-up. Negative 4 times negative 4 is going to give me what? Positive 16. 16 times negative 4 is going to give me what? Negative 64. So this negative 64 is still going to work as negative 4. Make sure you put the parentheses, cubed. So that one is still a perfect cube. Ready to move on? Okay. Now we're doing a bit of practice. This should be pretty quick. Evaluating these. So on number 6, 5/8 squared is the same thing as 5/8 times 5/8. Multiply your top numbers, your numerators. What's 5 times 5, guys? 25. And remember, if you forget that, you can go the other way too in your perfect square chart. We can